Problem 33 reads, a small block has a constant acceleration as it slides down a frictionless incline. The block is released from rest at top of the incline, and its speed after it has traveled 6.8 meters to the bottom of the incline is 3.8 meters per second. What is the speed of the block when it is 3.4 meters from the top of the incline? So diagram here is we have our block, initial velocity is 0 meters per second, final is 3.8 after it's traveled 6.8 meters down the ramp. We're looking for its velocity at 3.4 meters. So over here, put up our variables, which we just had. We do not have the acceleration or the time, but we can solve for the acceleration, which will be the same since our acceleration is constant, by using the equation where we don't need time. So v squared equals v naught squared plus 2ad. Plug in your variables, you get 3.8 squared equals 0 squared plus 2a times 6.8. Basic algebra, solve, and our acceleration for the block while it's traveling down the ramp is 1.06 meters per second squared. So we can now go and change up our variables. So our initial velocity is still 0. We're looking for the velocity at 3.4 meters. Since our acceleration is constant, we can use the same acceleration up here as 1.06 meters per second squared. The displacement now is going to be 3.4 meters, and we still don't know the time, but that doesn't matter. And we can use the same equation as v squared equals v naught squared plus 2ad. Again, basic algebra, v equals the square root of v squared plus 2ad. Plug in your numbers, and the final the velocity at 3.4 meters is equal to 2.68 meters per second.